Hi everyone. If you were just on my Facebook page for my Facebook Live just now, oops. I didn't know that I couldn't share my screen on a Facebook Live, so I apologize, but here I am making a quick little video for you on how to simplify radicals. It's really easy. I'm going to show you the best way. There's lots of ways to do it, but I wanted to be sure and show you how to do it my way, which is so easy, and the teacher can't trick you up. And if you're a parent just tuning in on this, I'm making this video so you can see what an online tutoring session would be like with me or with other tutors in other subjects you may have. So if you're interested in any tutoring one-on-one with me, I would love to help you. I tutor algebra and geometry through pre-calculus, and I also do college algebra. So just message me, and I'd love to help on my Facebook page at tag tutoring algebra and geometry. All right, so I'm going to share my screen and let you see what it looks like when you start tutoring with me. Usually always I start like I do here with you, where I talk with the person full screen like this, and then we go into the whiteboard. So I'm going to share my screen, and here I still am up in the corner, right? Well, that's what you would see if you were going to tutor with me too. I'd be up at the screen, you would just minimize me. So let's talk. I'm really excited about this topic because I've been doing it all week, simplifying radicals with all my students, and I thought, well, let's make a video because they all seem to be confused about it. And I have a really easy way to do it that the teacher can't trick you up on. So I'm not really going to go through the why is it this way. I'm just going to show you the way to get the answer, okay, on this particular video. I don't want to make it too long. So here we go. I am looking at the square root of 16. So the square root of 16, you may know the square root of 16 is 4. Turn off my lines. Square root of 15 is 4. And if you know that, you win. You're right. Why is it 4? The only thing I'm going to show you here is if I broke down 16, it would be 4 times 4, right? That's one way I could break it down. I have a pair of matching numbers. And under a square root, you're looking for groups of 2 that match. Okay? And so because I could get a pair of 4s, then I know the square root of 16 is 4. And that's probably, if you know your perfect squares, you know what? It's easy to do it that way, but I'm going to show you an even easier way to do this. So I'm going to take the square root of 16. Probably most people know it, but just for the sake of showing this, let me take it, and this is what I do, because it's just like you don't even hardly have to think. I'm going to do what's called a prime factor tree, but basically all I'm going to do is think of 2 numbers that multiply to be 16, and it can be any combination. You don't have to worry about, oh no, what kind of combination do I need? Just think of anything that multiplies. So I'm not going to choose 4 by 4 like I did over here. Let me say I think 2 times 8. And if I hit a prime number, then I'm going to circle it, and that just means that I couldn't break it down anymore. Yeah, I could go 2 times 1, but that's not going to really help me. So I'm going to break down 8, and that would be 2 times 4, right, gang? And then 4 would be 2 times 2. And that would be as far as I would break it down. And even now to this day, I've done this a billion times in my life as a teacher. And I still do this, and I circle the ends. And so I would regroup it together, and I'm not going to get fancy about it. I'm just going to put it in this case. I'll just write all 4 of them that I got, right? Now, before when we did the square root of 16 and got 4, I said on a square root, you need a group of 2, right? Why? Because it's a square root. And even though they don't show the index here, the index is a 2. And that little index right there, this is the key to the easiest way to simplify a radical. That index will tell you how big your groups have to be. So now that I broke it down, I'm going to circle any groups of 2 I can make. So there's a group of 2, and there's another group of 2. Now, when they come out as just a 2, not a 2 times 2. So I kind of think of it like this. I think of the square root symbol, the radical there, it's kind of like you're sitting at home. You're watching Netflix. You decide you want to go out, but you can only go out if you're a group of 2. And so if you're a group of 2, you are one group of 2. So I'm not going to bring out 2 times 2. You're going out together, so you come out as a 2. My other group of 2, okay, they're coming out of the house too. So there's another one. And now when you simplify radicals, it is always going to be multiplication. So now what is 2 times 2? 2 times 2 is 4. And I got the same answer I got the other way. I think I can hear you saying, geez, Grigsby, that's just a way longer way to do it than just knowing that it's 4. Well, okay, that's true, but say you don't know what the square root of 16 is, or the other ones that I show you, you don't have to freak out when it's time for a quiz or a test. You just go, oh, I'm just going to start breaking things down. That's good. That helps you have less test anxiety. And they're not always going to be this hard, right? So let's move on. So here I have square root of 75. It's not so obvious, and in fact, it's not even a perfect square. And you may say, well, how do you know it's not a perfect square? Well, because I've done this a million times and I know my perfect squares. But you don't have to just to do this. You're going to do, oh, I'm going to break it down. What multiplies to give me 75? Well, I know my quarters because I get quarters all the time. So I know if I have 25 cents that I would have 3 quarters if I had 75 cents. So 3 I can't break down, but the 5 I can break down into 5 times 5, right? And that, like, I didn't even have to break a math sweat over the whole thing. And it's new. Okay, so this is going to be like I did the last one. I'm going to put them down, and when I write them down here, I always put them from lowest to highest number. So I have a 3, a 5, and a 5. And by the way, if you're not sure if you broke it down right, you can multiply this out and make sure it gives you 75. If it doesn't give you 75, then you didn't break it down right. Okay, so here I am. I'm going to go for my groups again. Well, I don't have a pair of 3s this time, but I do have a pair of 5s. They're getting out of the house. They're going out together as a group of 5. Now this little lowly 3, it doesn't have a group to go out with, so it's got to stay home under the radical and watch Netflix, which isn't always a bad thing, people. And lo and behold, I've simplified it. So if you don't have a group, whatever size group you need, in this case it has to be a 2, right? Because it's a square root. If you don't have a group, then you're just going to stay there and watch Netflix under the radical and be there all by yourself. And it's that easy. You're just looking for groups of 2. So let me keep going here. Now, this one's a bigger number, so I don't know. I have no idea what this is going to be, but I know I could break this down to 15 times 10 because it ends in 0. 15 is 5 times 3. Those can't be broken down. And 10 is 2 times 5. So the math, the arithmetic's a lot easier than breaking my brain trying to figure out what the perfect squares are in 150, because honestly, I didn't know and I didn't want to work that hard. Okay, so here it is under the radical, and I've got a 2, a 3, a 5, and another 5. So again, it's a square root, so I don't have a pair of 2s or a pair of 3s, but I have a pair of 5s. They're going out as a group of 5. And the 2 and the 3, they got to stay home. They got to watch Netflix. Anything left underneath, you multiply together. So while I get 2 times 3, this just becomes 5. Square root of 6. And in just a really quick matter of seconds, I got the answer without breaking my brain. And I didn't even need a calculator to do that. Okay, so now, don't be freaked out that you see variables there, okay? And don't freak out that it's a 512. I'm just going to start breaking it down. I'm not going to hurt myself. I know 4 goes into it because I know it ends in 12 and 4 goes into 12. So I know that's going to be 4 times 1, 28. And if you didn't know that, you could use a little calculator to help you do the square root or divide by 4, right, to figure that out. So neither of those are done. So that's 4 is 2 times 2. Those are done. 128. Well, I know that ends in 4 because it ends in 28. And 4 goes into 28. So that's going to be 32. Those can both be broken down as 2 times 2. 32 is 4 times 8. And that's going to break down as 2 times 2 again. The 8's going to break down as 2 times 4. And the 4, holy guacamole, that is a lot of guacamole. That's a lot of 2s. Notice that I don't take any other thing on the branch except the very ends of the branches. So, okay, I'm not going to freak out that there's a billion 2s there. I'm going to stay cool. And I'm also not going to use exponents, although you could. I'm not going to. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to check again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I'm going to get my pairs. So I have a pair of 2s, another pair of 2s, another pair of 2s, another pair of 2s, and that little 2's got to stay home and watch Netflix. Okay, so it comes out as a 2 times another group of 2 times another group of 2 times another group of 2, and this little lowly guy has to stay home and watch Netflix under the radical. So now everything you bring out, everything that stays underneath is multiplication here, guys. So that's the cool part here. So 2 times 2 times 2 times 2 is 16. So you're going to get 16 square root of 2. And I didn't worry that that number was humongous. I just started breaking it down. Now that's not the final answer though, because I had a k squared, didn't I? You may think, oh no, not variables under the square root. Don't worry, the same rule applies for variables. So I have k squared. Well, k squared means k times k. And anything I have a group of 2 on a square root, I get to take out. Well, I've got a group of k's. Holy cow. So no worries, it works exactly the same. It's got to, or the algebra wouldn't work. So this comes out as just a k, and then the square root of 2, and nothing else is underneath there, so it's just 16k square root of 2. Boom, you're done. If your teacher's fancy on a square root, on a variable, you may have to put absolute values. I'm not going to go into that, but I will tell you that would need absolute values. Most teachers don't go that crazy on you, but they might, so I wanted to show you that. Okay, let's keep going. So I still have a square root, so I'm going to keep breaking it down. Again, 4 goes into that. You guys, learn my division rule on 4s. The last 2 digits, if they're divisible by 4, 4 goes into it. So it goes in there 54 times. I can break down 4 as 2 times 2. 54 is 6 times 9, so that's 2 times 3 for 6, and 3 times 3 for 9. So that's going to give me, under the square root, it's going to give me 2 times 2 times 2 times 3 times 3 times 3. Phew. And then I have k to the 4th, and I'm not going to worry about that. I'm just going to put 4 k's here because that's what that exponent means, right? That you have 4 of them. Ooh, baby, long one, but it's not hard. So again, pairs. Group of 2, group of 2, group of 2, group of 2. So this comes out as a 2, this comes out as a 3, this comes out as a k, this comes out as a k, and then I have a leftover 2 and a leftover 3 that have to stay home and watch Netflix. So altogether then I'll get 6k squared square root of 6, and that would be my answer. Now, if your teacher's persnickety about absolute value, I would tell you on this one, you don't need them because it's k squared, so that officially is the answer. Mum's the word. I'm not going to tell you any more about why, but stay tuned. I'll do another video on that. Okay, so still square root. You guys know the trick by now. Break down 96. It is different because there's a 7 out there. Notice I'm going to ignore it for right now. So I know that's divisible by 3 because 3 goes into 6. So it'll be 3 times 32. 2 times 16. And notice I'm breaking it down differently this time. 4 times 4. 2 times 2. You can break it down however makes you happy because you're just going to keep breaking it down anyway, so it doesn't matter. So I've got a 7 on the outside still, and now I'm go lowest numbers first. So 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 2s. That's what I have. I have a 3, and then m to the 3rd means I have an m times an m times an m, right? Pairs again, groups of 2. There's a group of 2. There's a group of 2. That one's not. That one's not. There's a group of m's, and that one's not. Okay, this 7 that was already there, don't worry about it, just bring it down. You know now everything's going to be multiplied. So times that first pair of 2's, a pair of 2's, and a pair of m's. And then underneath, I have a 2, a 3, and an m. Right? It's easy. So that's going to give me 28m square root of 6m. And that's going to be my answer. I will tell you, if your teacher's picky about absolute value, it would be 28 absolute value of m. square root of 6m if they were picky. Most teachers will take my box one. Easy, I'm not sweating it. I'm doing the same thing every time. That's what I love about this method. Now, I'm going to skip that because I think we've talked about it. So let's move on. Okay, I want to show you what happens now if it's not a square root, right? We know on square root of 16 we got 4 already, so I'm not going to do that one. But what if it's a cube root or a fourth root? And this is where people all week have been getting all stressed out. Don't worry about this. Just break it down. Break it down, people. Break it down. And you do it the same way every time. So 16 is 4 times 4. That gives me 2 times 2 and 2 times 2. So I'm going to get under the cube root. I'll get a 2, a 2, a 2, and a 2. Now, what's different is the index is a 3 now. So now I need groups of 3. All the other ones I did groups of 2 because they were square roots. Excuse me. So that little index is the only thing you have to pay attention to. Okay, so now if you want out of the house, you need to be a group of 3. There's a group of 3. So they come out as a group of 2. So they're a 2. You know, go 2 times 2 times 2. This little 2 is not in a group of 3, so he's got to stay home under the cube root. And it's exactly the same, except I'm looking for groups of 3. So notice when you're a square root of 16, you get 4. When you're a cube root, you get 2 cube root of 2. Totally different answers. So it matters what that index is. So don't be sloppy about the index, because that's going to help you simplify it. So now I have a group of 4. I'm not going to break it down again because I already know what it is broken down. So now it's 2 times 2 times 2 times 2. But now I want a group of 4. Well, I've got one group of 4. And so it comes out as a 2. Now notice I didn't have anything left at home, anybody left at home having to stay there and watch Netflix underneath the radical. If there's nothing left there, you don't have a radical anymore. So this just comes out as 2. And again, check it out. The fourth root of 2 is completely different than a cube root of 16, different than a square root of 16. But I'm doing the same thing every time. I'm just paying attention to how big my groups are. Okay, that's really the trick. I can't really trick you now. So 64, let me break it down, is 16 times 4. 16 is 4 times 4. So by the way, if along the way you happen to see, oh, I have repeat numbers and it happens to match what that is, you do not have to break it down. So you could stop right there and write it as 4 times 4 times 4 and go, oh, baby, I have a group of 3 because my index was 3. So I know this equals 4, and boom, you're done like that. But if you don't see that, there's no shame in that. I'll break it down over here on the 6th root. It's still, I'll go 8 by 8 just to show you it comes out the same no matter what you do. If I have 2 times 4, 4 is 2 times 2. So I'm just going to break it down all the way. I'm not going to worry about anything. And 2 times 4, and then 2 times 2. So notice I don't circle anything till I'm done breaking it down. So this time under the 6th root, I have 2 times 2 times 2 times 2 times 2 times 2. And so now, because it's a 6th root, I need a group of 6. I know, I could hear you shouting that from over there. Well, hello people, that is a group of 6. And so the 6th root of 64 is 2. Notice it's completely different than a cube root. And notice too that I broke it down exactly like I did before. I'm just looking for groups of 6 instead of groups of 3. That's really my trick. You just look at the index. So I wanted to bring this one in because it had a negative number on it. And so if it's an odd radical, I'm not going to go into a lot of detail on this. Negative numbers do not bug me. Negative numbers, A-okay. So when I break it down, I don't worry about the negative right now. I'm just going to break it down. I know because it ends in 0, it's 25 times 10. 25 is 5 times 5. Those are done. 10 is 5 times 2. So underneath the cube root now, I have a 5. I'm going to go in order, excuse me. I'm going to stick to my rule because I do try to do that even nowadays. So the 2 comes first. I have a 5, a 5, a 5, and then the x to the 4th means I have 4 of them. Once you get good at this method, you don't even have to write out the x's. You'll just know out of 4 x's, I can take 3 out. So sorry about my phone there. So groups of 3. So I have a group of 3 5s and I have a group of 3 x's. Now, because it was negative, I'm going to make it a -5 times a -5 times a -5. Check it out. If I have 3 negative numbers, it always is negative, and that covers the -250. So whatever you bring out of the cube root, you're just going to make it negative. That's all. And then I'm going to bring the x out, and then it's going to be a cube root. The only thing left here was a 2, and that would be my answer. If your teacher is picky about absolute values, that's the answer, because on odd radicals, you don't need absolute values ever. Okay, so don't be nervous if it's a negative. That's the point of that one. So this time I'm going to do it differently. I'm going to break down the 40, though, the same. 4 times 10, again, my trick there. 4 is 2 times 2, that's done. 10 is 2 times 5, easy peasy, that took me no time. I'm not going to break down the x's this time because I'm going to show you how I'm going to do this. But I'll do the number part. I always do the number part this way no matter what. X to the 8th I'm going to leave alone, and y to the 12th. So groups of 3, right? Because the index is 3. So I have a group of 3 2s. So that's going to come out as a 2. That 5 has to stay home. So I know I'm going to have a 2 on the outside and a 5 on the inside. Now let me show you how I do the x to the 8ths without writing it all out. So if x to the 8th means I have 8 x's. So if I know I need groups of 3, just think about it for a second. If I need groups of 3, how many groups of 3 could I get in 8? And I know I can get 2. So I'm going to bring it out as x squared. However many groups you make, that's what it is. Now, if I take out 2 groups of 3, that's 6, right? From x to the 8th, that would leave me 2 left over. See how I did that? So if you didn't see how I did that, this is basically all I did in my head. I took the exponent of 8 and I divided it by the index. That goes in twice. That told me I had x squared. And then 3 times 2 is 6. I took it away from 8, and that left me 2. And that's where I got the 2 left over on the x squared. But I don't really go through that long division. I just think about it. And I think you can too, because we've all done arithmetic, or we've all had to separate things out into groups. So check it out with y to the 12th. So how many groups of 3 could I make out of 12? Well, I can make 4 of them. So I would go y to the 4th, and that would be all of them, and I'd be done. To show that to you over here, if that doesn't feel comfortable to you, divide the index into the exponent. 3 goes into 12 4 times. That's where I got, that's where I got y to the 4th from. So that gave me the y to the 4th. And then 3 times 4 is 12. That gives me a remainder of 0. That means no y's left over. If I could spell, now you know why I typed earlier, don't you? Let me write that so you can actually read this later. No y's left over. And so I'm not going to put any y's under my radicand, my radical symbol. So got all fancy on you for a second. That's my answer. And on a cube root, I don't need to worry about absolute values. So that would be my answer. So say it's time to take a test and you're like, oh, good Lord, I don't know what x to the 8th would be. You know what? There is no shame in just writing it out. Okay, there's 3. There's 3 more. That gets me to 6. And then I'd have 2 left over, right? Boom, x squared with 2 left over. On the y's, oh, Lord. I know you need groups of 3. So as I write them out, I'm going to write them out in groups of 3, kind of with a little space between them until I get 12 of them. Now, this is really why you don't want to have to do it this way, because if it's a really big exponent, it could take you a long time. But there's my 4 groups of y's, and that's why it came out as y to the 4th. It's all the same rule. You can't trick me, people. You just can't do it. Okay, So I'm going to skip that one because I think you get the idea. Okay, this one, though, I did want to do. So say your teacher is getting all fancy pants on you, and she throws in some algebra here. Let me erase that dash mark that I made for no good reason. Man, my pen is not working right. Hold on. Try it again. There we go. So remember, I need groups of 3, right? So I'm not going to freak out that it's x minus 9. What I am going to do, though, is if I have x minus 9 cubed, doesn't that mean that I have 3 of them? So that would mean I'd have x minus 9 times x minus 9 times x minus 9. Kind of like if it were just x cubed, I write x times x times x. I write 3 of them. If it'd been x to the 4th, I'd put another one down there. I would just keep going till I had that exponent covered. Okay, groups of 3. Again, I'm not going to freak out. I have exactly, I'm going to change colors on you. That's how fancy I'm getting. X minus 9, well, I have exactly one group of 3 of those, right? Let me go back to my color here. You can see behind the veil here. So this is just going to come out as x minus 9, and boom, just like that, we are done. You don't have to write it out that way. You can just think about it. I could just think about that from the beginning because I know I'm looking for groups of 3. If I have a cubed, that means I have exactly one group of 3. And this one, absolute value, people, you don't need absolute value because it's an odd radical. Okay, so don't be worried about it. So, okay, now the teacher's adding a number in front and a group. So now on a square root, and if it helps you put a 2 there, there is no shade from me on putting the 2 there. So I need groups of 2, right? 25 is 5 times 5. There's a group. And then x plus 2 to the 4th means I've got 1, 2, 3, 4 of them, right? And I'm not even worried about the index. I'm just writing them out right now. So groups of 2. So I have one group of 2 right here, and I have another group of 2 right here. And you may think, oh no, do I have to multiply it out? No, people, because you're just bringing out the group. They come out as a group as x plus 2, excuse me. I am going to use parentheses just because it makes me nervous a little bit. And then that group comes out as an x plus 2. And I have this 5, and nothing was left over, so I don't have a radical. So I could write x plus 2 because I have 2 of them. I could write it as x plus 2 squared. Right? And that'd be my answer. No need for absolute value, people. So again, you could do the exponent thing. Take the exponent of 4 and divide it by your index of 2. That goes in twice with nothing left over. That's why I had 2 of them with nothing left under the radical. Easy, right? Once you know the trick on these. So let me show you one with the x and y already out there, but I can't trick you about it. So 32 is 4 times 8, 2 times 2, 2 times 4, 2 times 2, right? You could make the groups here, but I tend to get lost if I do that. So I'm just going to say ordered in some order here. So I have 2xy on the outside. I have 1, 2, 3, 4, 5 2s. I'm going to leave the variables the way they are now that we know the trick. And I have an index of 2, right? Which means I have pairs. Group, group. This comes out as a 2. This comes out as a 2. I already had a 2xy, right? So I'm bringing that down. And then, okay, x to the 6. How many groups of 2 do you have? Well, you'd have 3 of them, right? Because 2 goes into 6 3 times. Y, I'd have one group of 2, right? Because 2 goes into 2 ones. And the z to the 9th, if I have 9 z's, then I would have 4 pairs, right? But I would have 1 left over, so there's got to be a z there. Now that looks like a hideous, awful mess, but that wasn't hard. On that 9, let me show you on the z to the 9th, I would take 9 and I would divide it by 2. That goes in 4 times. That's where the 4 came from on the outside. Subtract 8 from it. That's 1 left over. That's why I had a z left. And now let me clean this up. So I have a 2 and a 2 and a 2. That would give me 8. I have an x from the outside, and then 3 more gives me 4 of them. I have a y from the outside, and another y would give me y squared, and a z to the 4th, and then another z left underneath, and that would be my hideously long answer. But I didn't sweat it. I just looked for pairs. Absolute value, people, this is the answer. There's no absolute value on this one. Okay. All right. So that's it. That's the gift that keeps on giving. Show all your friends. If you like what you see here and you're a parent looking for tutoring, or you're a student looking for help, tell your parents about my page. Message me here on Facebook or in YouTube. Go to my website, or you can email me at terrigrigsbymath@gmail.com, or go to my website. I'd love for you to go over there. Find out more about me. There's tons of information there about me there, and how the tutoring works and payment and all that stuff. And you can see more videos about me and my tutoring. All right, that's it, everybody. I hope this was helpful to you. Let me know if it was helpful. Hit a like button if you liked it. All right, everybody, have a good day. Simplify your life with radicals. Look for groups of whatever the index says. Have a great day, everyone. Bye.